Hey guys, I just want to share the files for this project. I have at the top, well, the file will be for the units at the bottom, uh, and the files for this one are on the same location, one folder above. If you go to the link, instead of going to the Gyrocam wireless, it will be one folder above that one. So the one on the top is the one I've been doing the videos on. And the ones at the bottom are going to be for the new videos for programming the NRF. The one at the top has the gyroscope on the right and the NRF on the bottom left. So we are going to be sending orientation data from the gyroscope through the NRF, and whatever unit is listening on the same channel and name will be able to get that orientation data. So this is the new unit, and you can see all the part numbers if you want to get the same part numbers. So we have an NRF 24L01 plus at the top. This is for wireless communications 2.4 gigahertz, and we'll be having the same standard 3 LEDs. From the right is red, yellow, and green. This is just a programming header for ST-Link. This is your standard, well, not standard diode, but this is just a regular diode as a safety guard against reverse connection. We have a servo header here with ground on the left, power in the middle, 5 volts, and then signal on the right. And the servo is going to be driven off of this 5 volt 3 amp regulator. So let me show you what the schematic looks like, and then you guys should be able to download the files and do the same thing. So this is the entire thing. I'm using your normal your cheap. This is the one of the cheapest ARM processors. Is the STM32G070KVT. I have a ton of those, that's why I keep using those. I also have a ton of Atmega Tinys of all different models, but I like this ones better because they have so many. They're so flexible in the type of connections that they have. So from the left, so just minimum connections, 3.3 volt connection, ground, and then the next 3 are just LED connections, red, yellow, and green. And then next is the SPI header for the NRF. So we have the clock, master in, master out, chip select, and chip enable. And then on 18 I have the pin that is going to control or send the signal to the servo. It will be PWM, which we haven't done yet. And these are just your programmer connections, those two. This is your NRF, same connections for the header, master in, master out, clock, chip select, chip enable, ground, and 3 volts. These are your 3 LEDs, and just bypass capacitors. One for the processor, one for the unit, and one for the servo. And then we have the 3.3 volt regulator with two microfarad capacitors on each side, on input and output. This is just the power header, power and ground. This will be connected to a 12 volt. It doesn't have to be 12, it has to be a minimum of 7. And this is your 5 volt regulator, 3 amps for the servo. Same connection type as the other one. I have two capacitors on each end. On the input, I have a zero point 0.1 microfarad capacitor, and on the output, I have a 2.2 because the initial kick, 220 microfarads, and that is because the initial kick, when the servo starts moving, it tends to draw a lot of power. So we want to make sure that this picks up the slack and it doesn't deplete the other one, causing the processor to reset. We have the ST-Link header and the servo header. And this is just the layout. So you will have access, well, the files are already uploaded. All of this is there, so you can just go and process the files if you want. I also uploaded my print file. This is what I print when I'm ready to start doing my my manufacturing. So I have the top and bottom. I was doing a batch of 2. So the top is upside down and this one is correct. Is it? No, it's the other. Yeah, upside down, and then the bottom is the way it comes. And then these are the ones for the solder mask, and you get 2 for the stencil. So you can put them, since you're going to be doing top and bottom if you decide to do that. For the ones for the stencil are a little bit smaller, as you can see. The pads are farther apart, but that's because they're thinner than this, and also thinner than this one as well. So I believe that's it. So you can download the files, and then in about a week I'm gonna start working on the code and uploading videos. It should be 2 videos in total for doing this to communicate with those with both. So here are the part numbers. This is the processor, regulator, diode, and then the NRF is 24R1. The full number didn't come out for some reason, but it doesn't matter. And it's just basic components. This was not plated through hole. It's just a wire through them. So these are all drills, and the wire, the drill size was what was it? 0.5 millimeters, which is, I think, is 19 mils. And then this is just a wire that I got from a stranded wire, and I just cut it into small little pieces and just push it through. This time I added 470 ohm resistors, so they won't be too bright, and you will be able to discern the 3 different colors. And the rest is similar to the red one. So let's see. To that one. So they're using the same processor, same NRF. This one has 2 additional units, and the bottom is just a receiver to drive a servo if you want to have a camera or whatever you want to have on it. So that's all I have. Enjoy.